Good evening, geometry students. We are going to start on chapter 4 tonight. We're going to talk about some transformations and congruence transformations. So let's recall that a transformation is a change in the position, shape, or size of a figure. Some different types of transformations are translations, which we also call slides, because you're sliding the figure over. Reflections, which are often called flips, because you're flipping the image across an axis or a line. And rotations, which are also called turns. We're adding one more, dilations, which is a stretch or a compression, meaning it's getting larger or smaller. So we've previously discussed translations, reflections, and rotations. What is new to us is the dilation. So a dilation will stretch or compress, so make bigger or smaller, a point's coordinates, x, y, the distance from the origin, which is the point 0, 0, based on a scale factor. So the scale factor is the number essentially that we're going to multiply by the point. So a dilation with a scale factor of k is greater than 0, and a center of 0, 0 maps the point xy to the point k times x, k times y. So we're multiplying that scale factor times our x and our y. Let's take a look at some transformations. We're going to graph them. So we're going to start with graphing the figure P, 1, 2, Q, 4, 4. So here's my P, here's my Q, and R, 4, 2. I'm going to go on ahead and connect those, and you'll see that it makes a nice triangle. And then we need to apply the transformation to it that we see up here, changing it from xy to x plus 2, y minus 5. That means that we're going to add 2 to each of the x coordinates and subtract 5 from each of the y coordinates. So our P primed is going to become 1 plus 2 and 2 minus 5, which gives us the new point 3, negative 3. Our Q primed is going to become 4 plus 2 and 4 minus 5, which gives us the new point 6, negative 1. And our R primed is going to be the point 4 plus 2 and 2 minus 5, which gives us the new point 6, negative 3. Okay, so let's go ahead and graph that over here. So 3, negative 3 is our P primed. Our Q primed is 6, negative 1, so Q prime. And our R primed is 6, negative 3. So that's our R primed. You'll notice the shape did not change shape or size, it just moved. It didn't turn, it didn't flip over anything, it just moved. So describing the transformation, it is a translation from the coordinates x, y, to x plus 2, y minus 5. Or in other words, right 2, down 5. All right, let's take a look at the next one. We're going to graph the figure. A is 1, 1. B is 3, 2. And C is 3, 5. And you'll notice it's another triangle. So now we are going to apply the transformation xy goes to negative x, negative y. So our A primed is going to become negative x, so negative 1, and our y stays the same. Our b primed is going to become negative x, so negative 3, and our y stays the same. Our c primed is going to become negative x, so it goes from 3 to negative 3, and our y stays the same. Okay? So all we're doing is, it says here, to change our x's to negative and leave our y's the same. So that's what we did. We changed all our x's to negative and we left our y's the same. Okay? So now let's go ahead and plot that. So a primed is going to be negative 1, 1, so that's my a primed. B primed is negative 3, 2. And C primed, my new point for C, is negative 3, 5. Okay. So it looks just like our original graph, but it has actually flipped from here over the y-axis. So the transformation would be a reflection or a flip across the y-axis. Okay, we have another one to do, so we're going to graph R, 1, 2, E, 1, 4, C, 5, 4, and T, 5, 2. So RECT, which happens to be a rectangle. Okay. And then we are going to apply the transformation from xy to negative yx. So we're going to flip each of our points and change the y to a negative, okay, or to the opposite sign. So our r primed is going to become negative 2, and so that's our negative y, and our x stays the same, so it becomes 1. Our e primed flips places, and our y becomes negative, so our negative 4 is first now, and our 1 is second. So our c primed, it's 5 and 4. We're going to flip their places, so it's going to become negative 4, because we have to remember when we flip it to put that negative sign on the y. 5. And our t primed is going to become negative 2, 5. So if you'll notice on each of those, all I did was flip the x and the y, swap their places, and change the sign on the y, okay, which is now the x value. So our r primed is negative 2, 1. Our e primed is negative 4, 1. Our c primed is negative 4, 5. And our t primed is negative 1, 5. So it is still a rectangle, but you notice it has turned. Okay? And in this case, it has turned from here to here. And on your papers, it's easier to see if you kind of rotate your paper so that your old image looks just like your new image, and you can see exactly what it's done. So if you take your paper and rotate it to the left 90 degrees, you'll see that it is a rotation counterclockwise 90 degrees, because that is when this original figure becomes and looks like your new figure. Okay, so try that when you're working on these. Okay, here's another one. It says apply the transformation xy becomes 2x and 2y. So this one right here, we're multiplying a k, so some scale factor, times our x and our y. So this is going to be a dilation. Okay, but let's go on ahead and graph the original figure. So k is negative 1, 2. Oop. So here's K. L is 2, 2. And N is 1, 3. Okay. So there's my original figure. Now I'm going to multiply everything times 2. So my K prime, if I multiply negative 1 times 2, I get negative 2. And 2 times 2 is 4. L prime, I'm going to multiply my X times 2. So 2 times 2 is 4. And my Y times 2. So 2 times 2 is 4. And then my N primed, I'm going to multiply my 1 times 2 and I get 2, and multiply my 3 times 2 and I get 6. So those are my new coordinates. Okay, so my K primed is going to be negative 2, positive 4. My L primed is going to be positive 4, positive 4. And my N primed is going to be positive 2, positive 6. Okay, so now you can see that it is the same shape, but it is larger. So this is a dilation with a scale factor of 2. And because our K was greater than 0, it's actually an enlargement. Okay. So if our K is greater than 0, okay, then it's an enlargement. And actually, it's got to be, I lied, I didn't write this down on my paper because I just remembered it. So K is greater than 1 is an enlargement, because if you have a K of 1/2, right, a fraction, then it's going to be a reduction. Your size is going to get smaller. Okay, so I apologize for that. K is greater than 1 is an enlargement. Okay, it's going to get bigger. I'm going to make this neater for you guys. Okay, yeah. Okay, and we'll talk about that more in a future lesson, but I just wanted to bring that to your attention so you can see it. Okay, so if K is greater than 0, but K is less than 1, then it's the reduction. Okay, then it's going to get smaller because it's going to be multiplied by a fraction. Okay. All right, let's take a look. A summary of the transformations. These are the ones we went over at the end of chapter 1. Okay. And then we've added a dilation to it. So you need to make sure that you remember these transformations, okay, and how you get each of them, or be able to look at a picture, turn your paper, and figure out how you get them. So a rigid transformation is also called an isometry. Okay, an isometry. And that is a transformation that preserves length, angle measure, and area. In other words, it does not get any bigger or smaller. It stays the same size and it stays the same shape. These transformations provide an image that is congruent to the pre-image. The transformations that create congruent images, in other words, rigid transformations, are our translations, our reflections, and our rotations, or any combination of those. Okay? If you use a dilation, then it gets bigger or smaller, and it is not a rigid transformation because it changes the size. Okay, so you can prove two figures are congruent by showing there are one or more translations, reflections, or rotations that map one figure to the other. So we're going to take a look at that. We're going to take a look at a couple of pictures and see if they are rigid transformations or not. So this says determine whether the polygons are congruent. If so, state the transformation. If not, explain why. Okay, so let's take a look at the first one here. So our A is 1, 1. Okay. So from there, we need to figure out, well, what did we do with this point to get it over here? Okay. Just looking at these, it doesn't look like they've turned at all, and it doesn't look like they flipped at all. So it's probably gonna be a translation, a slide. So let's figure out how far it had to slide. So to go from point A, which is 1, 1, to get to point P, which is -4, 2, what would we have to do? So 1 to -4, we would have to subtract 5. So that would be our x minus 5. Okay, to go from 1 to 2 for our y's, we would have to add 1. Okay, so that's what we have to do to go from A to P. We need to check and make sure that that is true for all of these points. So to go from B, 4, 1, to Q, -1, 2, let's double check. So to go from 4 to -1, we had to subtract 5. To get from 1 to 2, we have to add 1. Okay. So far, it's looking like that might be the pattern. Okay, and then our C, to go from 4, 3, to our R, -1, 4. Let's see if our pattern continues. So 4 to -1 is subtracting 5. And from 3 to 4 is adding 1. Okay. So these two figures are congruent. So triangle ABC is congruent to triangle. And let's go in the same order. P, Q, R. Okay? So P and A were the two. So A moved to P, B moved to Q, and C moved to R. Okay, so we want to keep them in the same orders. Okay? So they are congruent, and it is a translation, so a slide, and our rule was from XY, it moved X minus 5 and Y plus 1. Okay, so that's our reason. That is why. Okay. Let's take a look at this second one. So remember that if they are congruent, they're the same shape and the same size. These two figures, looking at them, we can see that they are not the same size. Okay, so no, they are not congruent. So triangle ABC is not congruent to triangle, and I'm going to go in the same order again. So P, R, Q. Okay, so we went from here to here, so we're going from here to here. Okay, because, what's our reason? Because, I don't know why I put a comma there. Because triangle PRQ is larger. Okay, so in other words, there was a dilation. Okay, and as I told you on the previous box there, dilations are not rigid transformations. They do not create congruent shapes. Okay, let's take a look at one more. It's a little bit more difficult. Okay, so we're looking at triangle ABC, and then we're looking at triangle PRQ. Okay, so if we look from ABC to PRQ, we can see that the very first thing that happened is that one of them turned. Okay, so ABC is our original shape, okay, and it had to turn first. Well, we could translate it first and then turn it. Okay, so we could have moved it first, but I see right off the bat looking at it that it's turned. So let's go ahead and turn this. So if you're looking at your paper, go ahead and turn it so that your triangle PQR looks like what your triangle ABC did. Okay, so how did you have to turn, okay, that paper? Well, we had to rotate it 90 degrees counterclockwise, which means that, and remember, we were going backwards, so now we have to restate it. We're going 90 degrees clockwise to get it there. So this is going to have to rotate down and around. Okay, and looking at your summary of transformations, we know that a rotation 90 degrees clockwise is x, y, 2, y, negative x. Okay, so our x and our y change places, and our x changes to negative. So let's go on ahead and do that with our points. So from A primed becomes 1, negative 3. Okay, so we're going to switch our points, our 3 and our 1, okay, and change our x to negative. So y stays the same, it just moves places, and x becomes negative. Our B primed changes to negative 1, negative 2, and our C primed changes to negative 1, negative 7. Okay, so that's our first translation. Okay, so now I'm going to go on ahead and graph that so that we can see it. So A is 1, negative 3. Okay, so this is my A primed. Okay. My B primed is negative 1, negative 2. Okay, so here's my B prime. And my C primed is negative 1, negative 7. Okay, so there is my new figure. Okay, C primed. So now looking at those, I forgot to label that. So now looking at those, I can go on ahead and see that now they moved. So they're going to move, and we need to figure out how many they move. So from A, let's start with A, how many back and how many up do we have to go to get from where we're at? We have to go from here, and then we have to go up. Okay, so let's count backwards. 1, 2, 3, 4, and up 1. Okay, so then from our new xy, we are then going to go backwards 4, okay, and up 1. And let's double check and make sure that's true for all of these. So C primed, we're going to go back 4, up 1. And B primed, we're going to go back 4 and up 1. Okay, so the first thing we did was a 90 degrees clockwise turn. And then we're going to do a translation or a slide. Right 4, up 1. Okay, so that is the transformations, the two transformations that create this new figure. Now looking at this new figure, there was no dilation. There was no dilation. Okay, it was just two rigid transformations. So yes, triangle ABC is congruent to triangle PRQ. That's the end of the lesson for today. Tomorrow we will be doing an activity on this lesson, so make sure that you're prepared, and I will see you all next time.